Welcome back. I'm going to work on 10 through 13 right now. We'll see if we can knock these out. Maybe I'll have a little better go at it than I had in the last video. So all of these problems, we're going to be using the chain rule. And so let's just dive in. What I'm going to do is kind of write how the composition looks for each of these problems. So I'll just start down here. So for number 10, the composition really is the outside function, which is just 2 times the inside function, which is x squared minus 2x. And that's raised to the third power. So there's a composition here. We have 2x cubed, and then we have x squared minus 2x. So here's how the chain rule works in real time. We're going to do the derivative of the blue stuff first, and we won't mess with the red stuff. So the 3 comes down and makes a 6. 2 times 3 is 6. Don't mess with the red stuff. Leave it alone, because we're not dealing with that right now. We're doing the outside function first. We brought the exponent down, so we have to do 3 minus 1, which is 2. And now here's where the chain rule part comes in. Now that you've done the blue stuff, you can multiply by the derivative of the red stuff. And since this is going to be a binomial, I'm going to include in parentheses. So this is going to be the derivative of x squared is 2x, and the derivative of 2x is 2. Okay, so if you make it there, you've basically got the right answer. Okay. Usually what we'll do is kind of rearrange the order of these things and maybe distribute the 6. I mean, there's different ways to attack it. So that's one version of the answer. Here's another version. 6 times 2x minus 2 times x squared minus 2x squared. That's a second version of the answer. But you might also see, I mean, we might want to factor that 2x minus 2 also. So here's another version. I'm not real worried about that part. If you get the green part, as far as I'm concerned, you've done the chain rule, and that's all we need. But you can see here that there's a factor of 2 that we can pull out. So a lot of times you'll see this is 12 times x minus 1 times x squared minus 2x squared. There's some other stuff we can do, but let's just leave it at this. We could go all day moving this thing around algebraically. We're just showing off when we do that. The calculus part is the green part, and then any one of these yellow answers would be fine also. That's it for the chain rule. And when we're doing it with powers of polynomials, we usually call that the general power rule, but they really just, we're really just doing the chain rule. The same thing applies to number 11. The difference is that the problem starts out in radical form. Oops. Got to use the right pen there. So on number 11, even though it's written as the square root of 2x squared minus 5x, when I set this up, I'm going to get rid of the radical and use an exponent so I can do my power rule. So that's going to be 2x squared minus 5x to the 1/2 power. And let's write that inside stuff in red. Oh, goodness, I'm having a day. So the function that was plugged in is 2x squared minus 5x. We usually call that g of x, or u, depending on who's teaching you. And then instead of the radical, we're going to raise it to the 1/2 power. And then in real time, here's what the chain rule looks like. We bring the 1/2 down. We do not mess with the red stuff at this point. We are doing f prime of g of x right now, if you read the official definition of the chain rule. So we bring the 1/2 down, don't mess with the red stuff. And then the new exponent is 1/2 minus 1, which is negative 1/2. Next to that, now we're going to deal with the red. So we're going to multiply by, this is the chain rule part, 4x minus 5. And if you've made it to there, you've done a great job, right? That's a derivative. Now, this is typically not the form you'll see the answer in, though. We're going to kind of rearrange these things algebraically as soon as I pick up the right pen. So, this is really a rational function. I've got this fraction here with the 1/2 with a 2 in the denominator. and I have this negative exponent here. And so the way you'll typically see this written as is on the bottom of this thing, we'll have the 2 from here. And we'll bring that whole expression that's raised to the negative 1/2 down, and we'll write it down here. But we're actually not going to write it with a 1/2 power because it started out as a radical, so we're going to write it as a radical down here. And that's this whole piece here. This whole thing gets stuck down there in the denominator. I'm going to erase that arrow because I don't want to confuse the issue. What we haven't dealt with yet is the 4x minus 5. It's just 4x minus 5. It stays in the numerator. So the real fancy version of this answer, and the one that's simplified that we typically will see, is, hold on a sec, oh my, yeah, is 4x minus 5 over 2 times the square root of x squared minus 2x squared minus 5x. That's the one we'll typically see. If you made it to the green, you did the calculus, you're doing great, but we really want to shoot for this rational function written with a radical at the bottom here because of the way the question was posed. Okay, feel free to ask questions on that one if you have them. In number 12, we're doing a composition that involves a natural log. I'll just write that one here. I'll scoot this up so you can see it. So it starts out as the natural log of 6x squared minus 7x. And if I'm following the pattern of my other problems, I'll write that 6x squared minus 7x in red. So the g of x is 6x squared minus 7x. The f of x is natural log of x. So I'm going to do this problem in 2 ways. I'll do it the long way first, and then I'll show you a little shortcut that you might want to use. So when we're finding this derivative, we're going to start by doing the derivative of the blue stuff. The derivative of the blue stuff is just 1 over x, right? The natural log. So for us, that's going to be 1 over the red stuff, which is 6x squared minus 7x. Do not mess with the red stuff right now, right? We don't mess with that until later. When we do the chain rule, we multiply by the derivative of that, which will be 12x minus 7. And so that is the derivative. But when we simplify this thing, we end up with 12x minus 7 in the numerator, right? Because I multiply that up, and 6x squared minus 7x in the denominator. So here's what I notice. I notice that the derivative is on top, and the original is on bottom. So if you want to think of this in terms of a catchphrase or a verbal cue, you could say derivative over original. In more casual terms, sometimes I've been known to just call this stuff junk, the junk in the parentheses, and then my derivative, I would just say, is junk prime over junk, right? Oops, you got to spell junk right, though. So if you want to sound more formal, you can use the shortcut derivative over original. If you want to sound a little less formal, you could say junk prime over junk. The point is that anytime you work with a composition involving the natural log of some function, you're going to have that format where the derivative is on top and the original is on bottom. And if you think of it in those terms, I think you'll feel a little more comfortable. Okay, the last question in this little section is another composition, right? It's e to the 4x cubed minus 2x. And I'm going to go ahead and run through that derivative down here. That is number 13. And once we finish that one, we'll just have one question left, which I'll do in the last video because there's several parts. So if our function is e raised to the exponent 4x cubed minus 2x, the 4x cubed minus 2x is our red stuff, right? It's the g of x that got plugged into the function e to the x. So we follow this the same way we do the other chain rule problems. The first thing I'm going to do is the derivative of the blue stuff. The derivative of e to the x is just e to the x. So it's just e raised to whatever the exponent is. Don't change it. Don't mess with the red stuff right now. Then after that, we multiply this thing by the derivative of the exponent. So that's going to be 12x squared minus 2. And then, so you've done the derivative if you've written that way, but just for clarity's sake, we usually write that expression in front so that there's no confusion as to what the exponent is. And then we'll put the expression with the e after that. Especially when we're handwriting our answers, sometimes people are sloppy and it's hard to tell where the exponent begins and the expression ends. So when you're writing this answer, go ahead and stick that derivative in front in parentheses if it's a binomial or a polynomial. And then your e to the whatever, e to the 4x cubed minus 2x in this case, put that second. Okay, so these questions, I think what we do, 4 or 5 of them, these are all chain rule problems, okay? We used the chain rule by identifying, our outside function and our inside function, the function that was plugged in, which we usually call g of x or u. I used red to identify those. And then you do the blue derivative first, the outside derivative first. Do not mess with the red stuff. And then only at the end do you multiply by the derivative of the red stuff, that function that was plugged in. Okay, so we've got one more problem to do, which I'm going to go ahead and throw in a final video here. And then we'll be done with these solutions, and you can, let me know if you have questions, of course. All right, take care.